So, what have you now accomplished? What can you say now about decimal numbers that are actually rational?
Well, the say the end of the number always has some repeating sequence.
Mm-hmm.
Yes.
And is that enough? I mean, if it has if you have a decimal number where it does have a repeating sequence at the end, is that sufficient to know that it's a rational number?
Yes. Because we can always multiply by depending on how many digits the repeating sequence is long.
Mm-hmm.
Multiply by 10 to that power, and that will shift that whole number over so that the ends of the repeating sequence still line up with the original x.
Mm-hmm.
Then when we subtract x, we now have a repeating zeros at the end of the number.
Mm-hmm.
And that leaves us with some number with a finite number of decimals divided by some number of nines, but another.
And how many, yeah, some number of nines, yeah.
Right.
Mm-hmm.
And at that point we can turn it into a normal looking rational number by moving the decimal over by multiplying by some power of tens.
On the top and bottom,
Right.
right, you shift the decimal over. Now, okay, great. Isn't that great?
That's wonderful.
I mean, you really feel like you've done something.
Yeah.
And it's real, and by the way, you have. So you have really shown how to take a decimal number that ends in a repeating thing, and you've seen all features of it, not just the ones where it starts with a decimal repeating, but you see why if it shifts over a little bit, you can still deal with it, and what. Great. This is really terrific.